Hello and welcome to the ABC Networking channel. My name is Dick van Oeveren, and in this video I will give you an overview of an exciting new feature that has been introduced in Aruba AOS-CX software release 10.1, which is virtual switching extension. I will first go through some basics on what VSX is, and in the second half I will show you how to set everything up. First, let me start by explaining what VSX really is by going through some slides. Let's start by giving a high-level overview of VSX. So really VSX is all about availability and guaranteeing maximum possible uptime. Whereas you typically find stacking technologies in the access layer, VSX is built for the aggregation and core. VSX provides redundancy in both hardware and software, and it allows for high availability by design during upgrades. With VSX you get active layer 2, layer 3 unicast and multicast. This means that you utilize all the resources that are available. It's a very efficient solution. Another great advantage of VSX is the operational simplicity and usability for configuration. Because the configuration is synchronized, there is minimal configuration required on the secondary switch. VSX is built on multi-chassis link aggregation and therefore provides virtually all the benefits of VSF except with better high availability. If we take a look at the switching virtualization technologies that are available, you can distinguish two main technologies. We have stacking and multi-chassis link aggregation solutions. The main difference between stacking and MC-lag is that with stacking you have a single control plane. This means that when there is a failure in the control plane, or in other words, if the master switch fails, there is a switch over to the backup control plane that typically resides on one of the other switches in a stack. A switch over means that it is important that the state of the sessions are maintained on the new master control plane. Normally for layer 2 traffic the switch over is pretty fast, but when you use dynamic routing, this means that reconvergence has to take place for layer 3 traffic. There will be downtime. You can minimize this by using features like non-stop routing or graceful restart technologies, but still there is a risk for downtime, especially for layer 3 traffic. Another aspect with stacking is software upgrades. When a software upgrade is performed on a stack, there comes a moment that you have to reload the master switch with the new software. If you do that, there will be a switch over to the secondary switch that becomes the master, which again means downtime. It's really difficult to guarantee network continuity during software upgrades on stacking solutions. Now here is where MC-lag comes in. When using an architecture with two switches that operate with MC-lag, each switch maintains its own control plane. This means that when there is a failure in one of the switches, only part of the sessions have to be rerouted to the other switch, which means a much better guarantee of network continuity. Another advantage of MC-lag is that you can really start thinking of performing an in-service software upgrade with MC-lag. The availability of the switches during a software upgrade is much better compared to a stacking solution. One disadvantage of MC-lag is that you have to configure both switches independently, which can lead to configuration errors. Virtual switching extension or VSX solve this problem for you. With VSX you have two data planes and two control planes. However, the goal is to have a single management plane. This means that when you configure something on the primary switch, the configuration on the secondary switch is automatically updated and synchronized. So this greatly simplifies the configuration steps that you have to go through for getting MC-lag with VSX to work. In addition, VSX builds on the advantages that you have with MC-lag. So you have a fully distributed environment for data and control plane, so not just for layer 2 but also for layer 3 operations. And with MC-lag you can configure an active gateway. So active gateway provides similar functionality as VRRP, but it has two main advantages. Main advantage being that with active gateway, both switches actively perform layer 3 operations. So there's no concept of a master or backup VRRP router. This means fully load balancing for layer 3. The other advantage is that it only takes one command per VLAN interface to configure the active gateway. Setup is really very easy to achieve. Another feature that VSX provides is something called active forwarding. Let's have a look at this slide and check out how VSX is dealing with layer 3 packets. Imagine that VSX member 1 is forwarding a layer 3 packet as shown on the slide. The router on the far end then sends back the response using the connection to the VSX member 2 switch. Now typically VSX member 2 should forward the packet to member 1 using the inter-switch link, so that VSX member 1 can process the packet. Now when you enable active forwarding for a given VLAN interface, this doesn't happen. When active forwarding is enabled, VSX member 2 will deal with the packet and will send it directly downstream to the bottom switch. So with active forwarding enabled, you can improve the performance by always selecting the shortest path between the source and destination. Now for the functionality, what can we synchronize with Aruba OS-CX release 10.1? Well, it's the most commonly used features that are supported at the moment. It's VLANs, ACLs, and active gateways. And I'm pretty sure that in subsequent releases, more functions will be supported for synchronization in VSX. So really, to summarize all the advantages, VSX provides a spanning treeless, active loop-free solution that is very easy to configure and maintain. In addition to active layer 2, VSX also provides fully session-based layer 3 load balancing through the deployment of active gateway. VSX is providing carrier-grade high availability by utilizing a dual control plane for better resiliency, unified management, independent software upgrades, and in-chassis redundancy for the 8400 and device level redundancy. And then finally, with active forwarding, VSX allows you to efficiently route information, minimizing the traffic on the inter-switch link. Now let's move on to the demonstration and setup. This slide shows you the setup of the lab environment. It contains two 8320s that we will be connecting through an aggregated link. In other words, the aggregated link will become the inter-switch link, and there is another link between the 8320s, and we will be configuring this link as keepalive. So whenever the inter-switch link fails without a notification feature, you will get a split brain situation where both switches will act as active layer 2 and layer 3 forwarding devices using the same IP addresses. And then of course that is well, an undesired situation. With the keepalive function, when there is a split brain, all the downlinks that are member of a multi-chassis link aggregation of the secondary switch will shut down, preventing all kinds of undesired things to happen. Now during the demo, I will configure VSX, create a couple of multi-chassis lags, and configure an active gateway, and then finally I will configure the keepalive feature and demonstrate what happens when the inter-switch link fails. Let's start from scratch. So I've got the two 8320s here, the primary on the left side, the secondary on the right side. Let's start with the primary. You can see the configuration, so there's nothing in there. There are some IP addresses configured that allow me to remotely access the switch. Other than that, there's no configuration. Now let's start with the link aggregation interface that will become the inter-switch link. So that's the lag interface. I do no routing, no shut, and I'm setting the lag P mode to active. So I'm doing active lag P. And then the next step is to assign the physical interfaces to that lag 111. No shut. lag 128. Okay, I'll do the same with interface 112, lag 128. Okay, let's do the same on the secondary switch. So create an interface, the lag interface, no routing, no shut, and lag P mode active. Okay, and let's assign the lag to the physical interfaces. No shut, lag 128. No shut, lag 128. Okay, so this should establish the link aggregation between the two 8320s. So if I do a show lag P interface, you can see that my lag is up and active. Okay. Next step is to get VSX working. So what we're going to do now is go into the VSX context. I have to do two things. I have to set the role of the switch, whether it's a primary or a secondary switch. So for this switch, I'm setting the role to primary. And I'm setting the inter-switch link as lag 128, because that's my link between the switches. I'm going to do the same thing on the secondary switch. So get into the VSX context. My role is secondary, and my inter-switch link is lag 128. And that's all for the VSX configuration. So let me show you the VSX status. Let me show you the status. You can see that my ISL is in sync. It's all operational. My peer is reachable. You can see the configuration here. So the ISL link is lag 128. And the platforms and the software versions that are running and the device roles of both switches. That's really cool. Next is to configure the MC lag interfaces. Because both switches can have different port members, we have to configure the lag interfaces on both switches. Once configured, we can then move to the primary switch for further configuration. Let's start with the primary switch here. So go into configuration mode. Let's create a lag interface one, which is a multi-chassis. Okay, what we're going to do is we are going to set the VSX sync for VLANs. I can also do a VSX sync for ACLs, so access lists or VLANs. Okay, so no routing, no shut, lag P mode active, and then let's create another one. Interface lag 2 multi-chassis, also VSX sync VLANs, no routing, no shut, lag P mode active. Okay, and now I'm gonna assign the link aggregations to the physical interfaces. So remember the slide that I showed you with the lab setup. So port 4 and port 5 are connected to respectively the access switch and the WAN switch. So let's go to 114 first. No shut. Lag 1. Interface 115. No shut. Lag 2. Now I have to repeat the same configuration on the secondary switch. So let me do that. Interface lag 1 multi-chassis, no routing, no shut. Because this is a secondary switch, I don't have to do VSX sync on here. I only have to do that on the primary switch. And set the lag P mode to active. And also interface lag 2 multi-chassis, no routing, no shut lag P mode active. And let's assign the lags to the interfaces again. 114. No shut lag 1. Interface 115. No shut lag 2. I've already configured the trunking or the link aggregation on the access and on the WAN switch, as you can see here. So I'm also using VLAN 10 and assigned that to the trunk. So I will be configuring VLAN 10 in a minute on the switches. But let me first show you the status of the link aggregation and see if everything is up and running. And you can see here that the link aggregations are up to the access switch and WAN switch, and let's do the same here. And you can see on the secondary switch the lag interfaces are up as well. So that's cool and that's working. Now let's create a VLAN and assign it to the to both the multi-chassis lags. Now the thing is, we only have to do this on the primary because the secondary will pick up. Well, it will synchronize with the secondary. So once you configure a VLAN on the primary switch, the primary switch will push that configuration automatically to the secondary switch. So let me first do a show running interface lag 1 so that you can see the running configuration. You can already see that although I didn't issue the VSX sync command, you can see that the command is there. So there is already something happening between those switches. Now let me create a VLAN, okay, on the primary. So VLAN 10, and I'm gonna VSX sync that VLAN. Okay, and I'm also going to create a VLAN interface. I'm going to assign an IP address to that VLAN. IP address 10.10.1.1/24. So I've got an IP address there. On the secondary, I can also create that VLAN and provide an IP address. That is, if I want to later on, if I want to use the active gateway functionality, I need to have that IP address on that VLAN. So I'm going to do that as well. VLAN 10, interface of VLAN 10, IP address 10.10.1.2/24. Let me just do another show running interface lag 1. You can still see nothing's there because I have configured nothing on the lag yet. Okay, which I'm going to do now. So I'm going to go to the interface lag 1 and I'm going to allow VLAN 10 to that trunk. So VLAN trunk allow 10. Okay, now let me check the secondary running configuration for the lag. You can now see that automatically the secondary switch has obtained the VLAN information from the primary switch and is automatically updating the lag interface. So let me do the same for lag 2. So you can see nothing's there. Interface lag 2. So I'm going to do a VLAN trunk allow 10. Actually, I have to allow 1 as well, officially, but you know. Okay, let's do 1 and 10. And let's see what's happening here. There you go. It's there. Let's configure the keep alive feature. This feature ensures that in a split brain situation, the secondary switch blocks the lag ports. It's really easy to configure. So what we will do is we will use interface 113 as keep alive link. So let's go to that interface. No shut. And let's configure an IP address on that interface. 1.1.1/24. And let's do the same on the secondary. Okay, let's see if we can ping. There you go. That interface is reachable. Now let's configure the VSX keep alive. So all you have to do is go into the VSX context and then configure the keep alive peer. So this would be 10.1.1.2, and then my source would be my 10.1.1.1. Okay, and I have to do the same thing on the secondary. So keep alive. Actually, what I'm going to do first is I'm going to show you the VSX web GUI here. So there is this with 10.1 you have this great new GUI that also contains the VSX information. So you can see here that you can get the summary information here, but also the keep alive information. So let's configure the keep alive and see what happens on the GUI. Peer 10.1.1.1, and then my source is 10.1.1.2. And my keep alive should be established. There you go. There's another parameter that you can set, which is called the link up delay timer. And the link up delay timer is used to set the time interval before the administratively shut down interfaces are activated again after the VSX has merged. And so in other words, when there's a split brain, the MC lag links are shut down. And when the VSX is operational again, it takes approximately, well, the default value is 180 seconds, but I'm gonna change that value to, like, say 5 seconds. So link up delay timer, you get a question mark, you see the default is 180 seconds, and I'm gonna set the timer to 5. And I'm gonna do the same thing here, link up delay timer 5. Okay. Okay, so let's put it to the test. What I'll do is I'll shut down the interswitch link on the secondary switch and see what happens with the downlink port. So this is a secondary switch. Let me just first show you the interface 114 brief. You can see that that interface is up. So that's your link aggregation interface, multi-chassis link aggregation interface to the access layer, and this the one to the WAN layer. Now let me shut down the lag interface and show you the interfaces again. You can now see that this port is disabled by feature. Okay, so the keep alive is detecting the split and it's shutting down all the MC lag ports on the secondary switch. Okay, let me show you the same one for interface 4. Is disabled by feature. Let me show you the interfaces here. 1/1/4. And you can see that those interfaces are up. They're on the primary switch. So what I'm going to do now is I am going to enable the link aggregation again. And let me just show you the interfaces. Still disabled by features, but because I've set the link up delay timer to 5, the port should become active very soon. So let me just wait another couple of seconds. and you can see the port is up again. And the same for, of course, for port 5 is also up. Last part of this demonstration is the configuration of the active gateway. As said, it's really very simple to configure the active gateway. The only thing I have to do is go to the Vlan interface. Let me just do a show running interface Vlan 10. You can see there's nothing configured, just the IP address. So what I have to do is I have to do two things. I have to set the VSX sync so that the active gateway is synchronized, and obviously I have to configure the active gateway. So let me just do a show running interface VLAN 10 on this one. You can see there's nothing there, and let me just do a VSX sync. No, let me just do an active gateway first. Active gateway IP 10.10.1.254 and my MAC address 0010. Okay, if I do another show running interface VLAN 10, you can see that the active gateway is configured. And now for the VSX sync, I can do that for the active gateways. Again, let me just show you the running interface here. There's nothing there. As soon as I VSX sync the active gateway for this VLAN interface and issue the command again here, you can see that the configuration has been synchronized. Really cool and really very simple to achieve. So this concludes the demonstration of VSX and in this video. So I hope that you liked it. If you did, please hit the like button. And if you have any suggestions or ideas for videos, we are happy to accommodate where possible and relevant. Thanks for watching, and as always, have a great day. Bye.